Welcome to the mind-bending reality of black holes and white holes. These cosmic phenomena are formed from the remnants of massive stars. When such a star has burnt out all its fuel, it collapses under its own gravity, forming a black hole. Now, this isn't just an ordinary space object. It's a region of space where gravity pulls so much that everything, even particles and electromagnetic radiation like light, can't get out. The invisible boundary surrounding this place from which nothing can escape is the event horizon. Venture beyond that, and you're met with the singularity, the core of the black hole. Here, all matter is crushed into an infinitely small and dense point. It's a place where our regular understanding of physics seems to break down. Incredibly, black holes aren't the only cosmic phenomena that stretch our understanding of physics. Ever heard of a white hole? A white hole, you ask? It's the hypothetical opposite of a black hole, a region of space-time that cannot be entered from the outside, but from which matter and light can escape. Now let's dive into the enigma of white holes. These hypothetical celestial bodies are quite the conundrum. They exist purely in the realm of theory, postulated by the laws of general relativity. In essence, a white hole is a time-reversed black hole. Imagine a black hole, but instead of hungrily swallowing everything in its path, it spews out matter and light. Despite their theoretical nature, the intrigue around white holes is palpable. They captivate scientists and spark countless debates. However, it's important to note that we have yet to find observational evidence of these cosmic wonders. So, for now, they remain a tantalizing mystery, a what-if in the vast cosmos. Now that we've explored both black and white holes, let's venture into the unknown. What happens when these two cosmic giants collide? Scene script. Picture this: a black hole, devourer of light, meets a white hole, the cosmic spitball machine. What happens next? Well, it's a clash of the titans on a cosmic scale. Theoretically speaking, the most likely outcome of such a cataclysmic collision would be the birth of a new larger black hole. Why? Because the outgoing matter from the white hole would be irresistibly pulled into the insatiable maw of the black hole. But the universe isn't so simple. The exact outcome of this cosmic dance depends on several unknowns. For instance, what's the precise nature of white holes? Are they the opposite of black holes, spewing out matter instead of sucking it in? If so, could they resist the pull of a black hole, leading to a cosmic stalemate, or would they eventually succumb, adding their energy to the black holes? In the grand cosmic dance, the encounter between a white hole and a black hole would be a spectacle of unimaginable proportions. One thing's for certain, the universe never ceases to amaze us.